In the world of positive displacement pumping, reduced speed operation is a common requirement. High viscosity liquids, shear sensitive liquids, abrasive liquids, or any combination in between require the pump speed to be reduced from the synchronous motor speed. One of the simplest solutions to do this is a gear reducer. These simple machines consist of one or more pairs of gears. The driver, typically an electric motor, turns the smaller gear at high speed. The smaller gear, which is the drive gear, rotates a larger gear, which is the driven gear, with a greater number of teeth. The ratio of the driven gear teeth to the drive gear teeth determines the ratio of a gear reducer. As an example, a reducer with a 10-tooth drive gear and a 30-tooth driven gear has a ratio of 3:1. The speed of the output shaft and the connected pump would be 1/3 that of the driver shaft and the connected motor. Gear reducers are simple, they're reliable, and they're highly efficient. So what's the downside? Well, there are a few. An additional piece of equipment does mean extra cost to the added purchase price of a pump unit. An additional piece of equipment also means added length and weight to the overall pump unit. Gear reducers are also typically oil lubricated, which means the oil condition should be monitored and the oil needs to be periodically replaced. These counterpoints can lead some to look for other options to reduce the speed of their pump. One way to address all three is to reduce the speed of the motor. And one of the most common ways to do that is to use a VFD, or variable frequency drive. Is it possible to just remove the gear reducer and use an AC motor with a VFD drive? The short answer is yes, but to do so requires oversizing the motor to the application. And depending on the speed reduction required, it may be a more expensive and larger overall size solution after all. So why is that? Let's think of the gear reducer another way. Think of it as a torque converter. Power in equals the power out. On the input side, the speed is high and the torque is low. On the output side, the speed is low and the torque is high. As a result, the coupling on that low speed, high torque side between the reducer and the pump is larger and capable of transferring higher torque. The reducer allows us to run that low speed, high torque load, in this case the pump, with a low torque, high speed motor. So what happens if we remove our torque converter and just run the pump directly from the motor via a VFD? As you're likely aware, motors run with VFDs provide constant torque. This can lead some to an incorrect conclusion that they provide constant horsepower. Let's look at the basic torque equation. Torque is equivalent to the power times a constant divided by the speed. If we decrease the speed, but the torque is constant, then the power available decreases. In other words, if a motor is running at half its speed via the VFD, it is only capable of half its rated power. As an example, let's consider an application where the desired pump speed is 600 RPM and the required power is 10 horsepower. Option 1, using a gear reducer. Let's use a 4-pole 60 Hz motor. In the US, that's approximately 1800 RPM. With a 3:1 gear reducer, as I previously described, the pump speed would be 600 RPM and require a 10 horsepower motor. Option 2, if we were to just use that motor and a VFD drive, the same 4-pole 60 Hz motor would be going approximately 1800 RPM, and then we lower the frequency to 20 Hz using a VFD, that's still 600 RPM, but it's running at 1/3 of its synchronous speed. It now has only 1/3 of its rated power available, or approximately 3.3 horsepower. This is not going to be enough power to run the example pump at these conditions. This means that the motor size must be increased to 30 horsepower at its synchronous rating to have 10 horsepower still available when running at 1/3 of its synchronous speed. This larger motor means extra cost, extra size, and extra weight, and it nullifies a lot of the rationale for omitting the gear reducer altogether. For slight reductions in speed or a desire to easily vary the speed, a VFD is a great option to consider. But for considerable reductions in speed, a gear reducer is likely a better option. And there are other options to reduce the size of the unit while still using a gear reducer. Gear motors, C-flange mounted gear reducers, and right-angle bevel or worm gear drives have all been used to reduce unit sizes while still utilizing gear reducer drives. So don't fear the gear reducer. These simple machines are still the best and most reliable option when reduced speed is needed.